So today's notes are 7.6, and the objective today is to solve quadratic equations. And remember, we're kind of wrapping everything up here today. Remember, when we're solving quadratic equations, what we're really trying to do is find the x-intercepts. So where does this graph cross the x-axis? So that's what we're going to be doing today. And remember, to find x-intercepts, what you're going to do is you're going to let y be 0. So to find the x-intercept, remember, we're kind of making a table, and we're letting y be 0 and trying to figure out what x is going to be. And here's the key to solving quadratic equations. The key is that the quadratic equation must be in factored form. That's the reason we've spent almost 2 weeks now learning how to factor. So we're going to use what we've learned so that we can solve the quadratic equation and find the x-intercepts. This part is actually going to be easy. The hard part was trying to figure out how to factor. But once you have that quadratic in factored form, it's very easy to solve. So in number 1 here, the quadratic equation has already been factored for me. So all I have to do is solve the quadratic, and the way that I do that is I take my factors, x minus 8, and let it be 0, and then I also take x plus 1 and set it equal to 0, and then solve them. Well, if I move my 8 over, I know that 0 plus 8 is 8, so x is equal to 8 is one of the solutions to this quadratic. And then the other solution, where this curve crosses the x-axis, is also at -1. So there are two intercepts here. We've got 8, 0, and -1, 0. Now I think for these first ones, because they don't specifically say tell me the intercepts, you're actually just going to enter the two solutions, 8 and -1. Later they'll ask you to write them in intercept form. So for right now you can just put 8 comma -1. Now this is not a point. These are just the two solutions. On number 3, again, I've got this quadratic is already factored for me. So I'm just going to set both of the factors equal to 0. So I've got x equals 0. So one of the x-intercepts is 0, 0. And then x plus 2 equals 0. And so x has to be -2. So the two solutions are 0 and -2. Number 5 is already in factored form, so I've got 8x minus 9 equals 0, and then 6x plus 9 equals 0. So now I'm going to solve both of those. So I'm going to move my 9 first, so 8x equals 9. Divide both sides by 8. And so one of the solutions is 9/8. And then the other point where this curve crosses the x-axis, if I move my 9, I have 6x equals -9. Divide both sides by 6 and reduce, so x equals -3/2. So these are the two solutions to my quadratic. Now when we get to number 7 is not in factored form. So the first thing I'm going to have to do is factor this quadratic. So I want multiplication problems that equal -18 and add to be +3. And +6 times -3 is -18, and +6 plus -3 is +3. So there's my factors, x plus 6 and times x minus 3. Now I'll set both of those equal to 0 to solve the quadratic. So x plus 6 equals 0, so x is -6. X minus 3 equals 0, so x is 3. Number 8, the quadratic is not in factored form, so the first thing I want to do is factor. And x squared minus x, there's a common factor. They both share an x. So I'm going to factor out the x. When I factor out the x, I've got x times x minus 1 equals 0. And remember, it's because x times x is x squared, and x times negative 1 is negative x. So now I'm ready to set both of those factors equal to 0. So I've got x equals 0 and x minus 1 equals 0. So this one's already solved for us. The other one will be just 1, because 1 minus 1 is 0. So the two x-intercepts are 0, 0, and 1, 0. And again, they don't want you to write them as intercepts on this question. They just want you to write the two solutions, so 0 and 1 for the x's. Now number 9 is not factored, but the difference on number 9 is that the 40 is on the right side of the equation, so this is not set equal to 0 right now. So the first thing I need to do is move the 40 to the other side of the equation, and when I move the 40, there's not going to be anything left on the right hand side of the equation, so that means that that is now 0. So when I move the 40, don't forget to make it negative, and now it does equal 0. So now I can solve this quadratic. This quadratic is not in factored form, so that's the first thing that I'm going to need to do. Now, since there's not a number in front of x squared, I don't need to do my shortcut method, the slide and multiply and slide and divide and slide. Don't need to do that shortcut method. So I want to think of factors of negative 40 that would add together to be negative 6. So since I want the multiplication to be negative 40, I know that I'm going to have one positive number and one negative number. So I know that negative 10 times 4 is negative 40, and negative 10 plus 4 is negative 6. Now I'm ready to solve the quadratic by setting these two factors equal to 0. So x plus 4 equals 0, so therefore x must be negative 4. And then x minus 10 equals 0, so x must be 10. Okay, finally on number 13, they're going to start asking for these solutions to quadratics to be written as x-intercepts. So in order to find x-intercepts, remember I need to just set this equal to 0. And this already is in factored form, so I just want to take both of my factors and set it equal to 0. So I've got 7x plus 6 equals 0, and x minus 3 equals 0. So 7x equals negative 6, divide by 7. So x is negative 6 over 7. So that means that one of my intercepts is negative 6/7, 0. And then another intercept is 3. Because if I take this and move it over and add 3, so my other intercept is 3, 0. Now remember, there's two x-intercepts because this is going to be a u. So, if I graph that on the x and y axis, it's going to hit the x-axis twice. So that's the reason there are two x-intercepts on quadratic equations.